Hello, class 12th physics, ray optics, important questions for boards as well as for JEE and NEET. Before that, have a look on these common expressions: refractive index, speed of light in vacuum to speed of light in medium, or wavelength of light in vacuum to wavelength of light in medium, sine I to sine R, or 1 upon sine IC, this is critical angle, or if we talk about some depth, so real depth upon apparent depth. Other than that, there is for spherical surface, any spherical surface which is separating two media, if refractive index of denser medium is eta 2 and rarer medium is eta 1, then and refraction taking place from rarer to denser, then eta 2 by v minus eta 1 by u equal to eta 2 minus eta 1 upon r. And similarly, Lenz-Meeker's formula 1 upon f equal to 1 upon r1 minus 1 upon r2, eta 2 1. Eta 2 is the refractive index of material of that lens. 1 is that medium in which that lens is placed, minus 1, and that is equal to 1 upon v minus 1 upon u. This is called Lenz equation or thin lens formula, and which is further equal to power of the lens. There are other formula also, but I am interested here with the questions which I have taken are somewhat related to these only. One more thing, if I talk about this thin lens formula, then there is magnification also. So it is linear magnification, which is hi upon ho, which is equal to v upon u, and there can be areal magnification. If we talk about surface area of object and image, then area of image upon area of object, which is equal to v square by u square. All right, first question. So here we have question number 1. Two similar plano-convex lenses are combined together in 3 different ways. Find ratio between their focal length. All right, so for plano-convex lens, 1 upon f is equal to refractive index minus 1, actually glass with respect to air, or 2, 1, whatever it is, and 1 upon r1 minus 1 upon infinity, because plane surface is there. So one of the surface will have some radius of curvature and other will have no radius, actually infinite radius of curvature for plane surface. If you think that this should be written as infinite, then according to sign convention, the second radius will be minus of r, so minus minus will turn out to be positive. So ultimately, for plano-convex lens, this is the formula. And now if we join two lenses, then we know that formula 1 upon f for combination equal to 1 upon f1 plus 1 upon f2, which is irrespective of the way by which they are joined together. So in each of the case, focal length will be same. Here it will be this thing plus this thing, here also, here also. So ratio between their focal lengths will be, we will write that for all the combinations, net focal length will be same, irrespective the way they have joined. For each it will be this. Which is eta minus 1 2 by r. That's all. So the ratio will be 1:1:1. So a convex lens of focal length 20 centimeter is made up of glass of refractive index this one. Find its focal length when it is placed in a medium of refractive index 4/3. Remember this thing. Some people will using this formula 1 upon f equal to eta minus 1 1 upon r1 minus 1 upon r2. They will follow this formula, and in first case they will put this here, no problem with that, but in second case they will put this here, which is wrong. Actually, this is why we have to put some subscripts like 2 1 or glass with respect to air. In first case it is eta ga, glass with respect to air. It is focal length when it is placed in air. Now what happened, if it is placed in a medium, then it is eta gm minus 1 1 upon r1 minus 1 upon r2, and if we divide both of them, then finally it is fm equal to eta, oh god, it is not eta ga minus 1 upon eta gm minus 1 multiplied by f subscript a. Some people might wonder, then how is it? So do a little bit of algebra here. Divide both the equation, this will cancel out here. It will be simplified as fm upon fa, then cross multiply fa here. And now we know eta ga is 3/2, but we don't know eta gm. This is the key point of this type of question, when the lens is placed in any other medium other than air. In that case, don't take this as directly in the formula. Instead, do one thing. First find this eta g with respect to m. So we can do this work here. eta gm is eta g is 3 by 2, eta m is 4 by 3. Oh, I forgot to tell you that eta gm is eta g by eta m. And if we simplify this, it will be 9 by 8. Now we can put these values here, 3 by 2 minus 1, 9 by 8 minus 1, and FA is 20. So you can solve by yourself. This one is unnecessarily complicated problem. A lens is placed between source and light and a wall. Source of light and wall. It forms image of area A1 and A2 on the wall for two different positions. Area of source is okay. So aerial magnification M, I would write A. Aerial magnification it is. It is equal to area of image, which is A1 in case 1, upon area of object, area of source, we can say. I'm writing this as they have asked us. In the same way, M for second case is A2 by A source. Now, most important part of this problem, this lens. Actually, source, position of source is fixed and position of wall is fixed. And they have said that this lens, position of this lens will be changed. Actually, they haven't given this information directly here. But the thing is, lens is placed between source of light and a wall. Both are fixed. It forms images of area this and this on the wall for its two different positions. So lens has two different positions. Wall is on its place and source is on its place. Now it is only possible when if this distance, let us suppose, is x and this is y, then if this is y, then it will be x. So if they change their position in such a way, remember there are 6 common diagrams, ray diagram for convex, in which we can see situation get reversed when we place the object on certain positions. So if we follow this pattern, then in case 1, let us suppose that time image distance is y and object distance is x, then it will be y by x square. And in the same way, here it will be x by y square. And if we multiply both the equation, we will get a1 multiplied by a2 upon a source square, and that is equal to 1. And now you can solve it yourself. Next, in figure of, oh, I haven't drawn it. So here it is. Okay, in figure, this figure, an air lens of radius of curvature, short form I've written it like this, 10 centimeter. So it means R1 equal to plus 10, R2 is minus 10. Okay, so no problem with that. 1 upon F equal to eta of air with respect to glass, no problem with that. This is glass, this is air. Minus 1, 1 upon R1, which is 10, minus 1 upon minus 10. And this one is air upon glass. So refractive index of air is 1, refractive index of glass is 1.5, minus 1. This is 2 by 10 then. And I think now you people can solve it. The interesting thing I want to reveal here is despite of this convex shape, this value is negative. So it will act as diverging lens. So shape only does not determine its nature. It is okay. Water, okay, in a tank is 18 centimeter deep. It has refractive index 7 by 4 and convex surface of radius of curvature 6 centimeter, and it acts as thin lens. Actually they have misguided by using this term thin lens. Well, if you want to use lens formula, because for here this part you can use lens formula, but the problem with lens formula is it is a final product, it is the end result, and it is applicable if medium on both the sides is same, but it is not here, so we can't use that. Then why they have mentioned it? In order to avoid to neglect distances taken from this level or this level, we can assume both coinciding on the same point. Okay, so here is that source, that object S, and it is 24 centimeters, 24 centimeter above water surface, but as it is acting as thin lens, so this is also considered as 24 centimeter. So that was really tricky information, and they are trying to misguide. So okay, now we will move on. So that relation, eta 2 by v minus eta 1 by u is equal to eta 2 minus eta 1 by r. We can apply this, and eta 2 is 7 by 4, v we don't know, eta 1 is 1, that medium is air, upon u 24 negative, of course, eta 2 7 by 4 minus 1 upon r is 6. So this will be 3 by 4, that is 3 by 24, that is 1 by 8. Okay. Next, we can take it here. 7 by 4v is equal to 1 by 8 minus 1 by 24, which is 1 by 12. I'm not showing entire that mathematical part, and try to develop this ability to solve, to do such calculation mentally as much as possible. So v is equal to 12 by 4 multiplied by 7, which is 21 centimeter, and this is positive. I mean, so 21 centimeter is somewhere here. 21 centimeter. It is its image. And now it is acting as an object, or we can say it is uh, real depth, and we have to find apparent depth. So real depth upon apparent depth, that is we require to find, is equal to refractive index for this refraction, denser to rarer refraction. So this medium with respect to this medium. Remember, as I previously shown you, real depth upon apparent depth. This is the refractive index of medium in which that real depth is. Actually, it is refractive index of that denser medium with respect to air, with respect to rarer medium. Denser to rarer, that refraction is taking place. So also here it will be refractive index of what is it? Water. All right, so now situation is something like this. Here is the object. Let us suppose, okay, so this is how ray would go if there would be no medium other than this would exist. Okay, but it is also there. So now if you could remember that derivation of apparent depth, in which if I magnify this, not like this, it will look as this one. It has refractive index 7 by 4, it has refractive index 4 by 3. So it will bend away from the normal. So this ray will converge somewhere here. If I produce these somewhere here, I mean this one is this, and this one is this. So this is the angle of incidence. So also this is I, and this is the angle of refraction. Okay. And for a close approximation, this hypotenuse for this triangle and this hypotenuse can be considered approximately equal to this side and this side, this entire side. I mean this depth, I'm writing it, it is final distance, so v I'm writing, and this one as v dash I'm writing. So in fact this should be written as v dash. Okay, and what next? The final thing is that expression, refractive index in this medium, I'm calling it eta, that was oil, and eta water. So eta oil multiplied by sine I is equal to eta water multiplied by sine R. And eta oil is 7 by 4. And in the place of sine I, we have to put this entire distance perpendicular, this perpendicular which is common in both. So perpendicular, I'm writing P upon hypotenuse. In the place of hypotenuse, we are approximating it to V prime, is equal to eta W, which is 4 by 3 times sine R, again P, this distance, which is perpendicular for that, upon, this is final V, this is cut, and 7 by 4, oh, I can do this also, which is equal to 4 by 3 into final V. So this V is equal to 7 by 4 multiplied by 21 into, sorry, this is 1 upon V, 1 upon V, 3 upon 4. Oh, so finally V is 16 centimeter. This is 16. So that was really a confusing question that was asked in IIT exam, JEE Advanced actually. So two things which were essentially very confusing one. First one was this surface. So we didn't use that lens formula for this because, as I have said, that is a final product. So we have to go through that derivation process. And here, once again, that was difficult how to use that apparent depth type concept, because this time it wasn't the case of that apparent depth or something. But using that idea, we can end up with this result. So that's all.